Hey everyone, and welcome. Have you ever been driving down the highway, seen a huge field of solar panels right next to a bunch of wind turbines, and just thought, why did they put them right there? Well, today, we're pulling back the curtain on the secret science behind it all. It's a really fascinating puzzle of data, engineering, and of course, nature.
So let's just jump right into that big question. Why are solar and wind farms such common neighbors? Is it just, a convenient use of a big patch of land? Or is there something much, much smarter going on?
Well, as you probably guessed, the answer is way more strategic than just finding a sunny field or a windy hilltop. The real genius here is in how these two different power sources work together to solve one of the biggest problems in renewable energy.
And that brings us to the absolute core challenge for renewables, a problem that engineers call intermittency. You can think of it as the big puzzle we have to solve if we want to power our world reliably with clean energy.
I mean, it's a simple fact of life, right? Solar panels don't do much at night, and wind turbines, well, they're not much use when the air is perfectly still. This up and down nature is probably the single biggest hurdle to building a stable 24/7 power grid that runs on these sources.
But of course, engineers have a really elegant solution for this. It's called a hybrid system, and it is the absolute key to turning these on-again, off-again resources into a dependable, rock-solid powerhouse.
A hybrid energy system, or HES, it's pretty much what it sounds like. You combine two or more different energy sources. Most of the time it's solar and wind, often with some big batteries for storage, but it could also include things like hydropower or biomass. The whole point is to smooth out the bumps and create a much more consistent, reliable flow of electricity.
But here's the thing. Before even one panel gets installed or one turbine blade gets bolted on, a huge amount of work goes into picking the perfect location. Because the site you choose determines everything, from how much power you can actually generate, to the costs, to whether the whole project will even be profitable in the long run.
So, how in the world did they find that perfect spot? It really boils down to two key processes that have to work together perfectly: site assessment and resource mapping.
Let's break that down. Think of it this way. Site assessment is all about the what and the why. What are the goals of this project? What does the community need? What's the actual land like? On the other hand, resource mapping is all about the how much. How much sun does this place actually get? How much wind? It's all about measuring what nature has to offer right there.
So yeah, to put it simply, site assessment defines the mission, the what and the why, and resource mapping tells you if you have the natural firepower to pull it off, the how much. You absolutely have to have both to make a project work.
Now, when you're looking for a good solar site, it's way more than just, is it sunny here? Engineers measure the total available sunlight, which has a fancy name, Global Horizontal Irradiance, or GHI. Think of it as the total amount of solar fuel available. But they also have to look at temperature, because, funnily enough, solar panels get less efficient when they get too hot, and they have to account for stuff like shading from nearby hills and even soiling, which is just how much dust and dirt is going to cover up the panels over time.
And for wind, it's just as detailed. They're measuring wind speed, but not down on the ground. They measure it way up high, like 80 to 100 meters in the air, right where the center of the turbine will be. Wind direction is also super important because you have to arrange the turbines to avoid what's called wake loss. That's basically one turbine creating a wind shadow of choppy air for the one behind it. And yeah, they analyze that turbulence too, because it causes extra wear and tear.
Okay, now we get to the really cool part, the secret ingredient that makes these hybrid systems work so well. It's a concept called resource complementarity.
Resource complementarity is basically what happens when your power sources are on different schedules. It's like the perfect energy tag team. The sun is obviously strongest in the middle of the day, but the wind, that often picks up in the evening and overnight. So when one resource is winding down, the other is ramping up, which creates this much smoother, much more continuous supply of power.
And the research puts it perfectly. Complementarity is literally a measure of how smooth and stable that combined energy output becomes. You're taking two things that are variable and, by putting them together, creating something that is way more stable.
And check this out. This is what that looks like in the real world. This map shows the solar and wind complementarity across a region. Those green areas, those are the sweet spots. Those are the locations where the solar and wind resources are most out of sync, giving you that steady, reliable supply we've been talking about. To get really specific about it, engineers use a metric called the Complementarity Index, or CI. It's pretty simple. A score of 1 means you've hit the jackpot, perfect complementarity. A score of 0 means there's no complementarity at all. Maybe the sun and wind are both strongest at noon, which doesn't really help. Anything less than 0 is actually worse than having just one.
All right, so let's see how all this data actually leads to a final decision. We're going to walk through a quick, simplified example of how you'd take all this information and actually choose the best site.
Okay, imagine this is your job. You've got to pick between 3 different spots. Site A has the most sun, Site B has the best wind, and it's also closest to the power grid, and Site C has the most land available. Just looking at this, which one would you pick? It's not so obvious, is it?
Well, to get a real answer, analysts use a data-driven method. First, they normalize all the data, which is just a fancy way of saying they convert everything to a common scale, like a score from 0 to 1. Then, and this is crucial, they weight each factor based on what's most important for the project. So if solar power is your #1 priority, you'll give the sunlight score more weight than, say, the land size. And then you just calculate the final weighted score for each site. And when you run the numbers, look at this. A clear winner pops out. Site A, which, if you remember, only had the best sun but wasn't the top dog in any other category, it actually comes out on top with the highest score. And that's because it has the best overall balance of all the factors we cared about.
And if you look at it on a bar chart, it's not even close. Site A's score is way higher than the others. It's just a perfect example of how this kind of deep analysis can take a really complex choice and give you a clear, data-backed answer.
And that is really the main takeaway from all of this. The perfect spot for one of these hybrid projects is almost never the place with the absolute most sun or the absolute strongest wind. It's the location that has the best balance of all the critical pieces of the puzzle.
So the next time you're on a road trip and you see those solar panels and wind turbines standing together, you'll know it's no accident. You'll know it's the result of an incredible amount of data, careful planning, and a whole lot of science. It kind of makes you wonder, right? What other hidden data and decisions went into shaping the world all around us? Thanks so much for joining us.